For example, let's calculate the inverse of this matrix. First, the determinant is 4 times 6 minus 7 times 2 times swap 6 and 4, add a negative to 2 and 5, 2 and 7. So that's going to be 24 1 over 10 times that, which makes it 0.6 minus 0.7 minus 0.2 and 0.4. So that is the inverse of that matrix, which means if we multiply these two, we will get 1 1 0 0. That's the identity matrix. You can try that. Okay. Now, what if it's a larger matrix? What if it's 3 by 3? Okay, if it's a 3 by 3 matrix, again, you need to do two things. Calculate its determinant, 1 over that, times adjoint of A. So first, let's see what is the determinant of A. So basically, consider the first row. Pick each element in the first row. 1, 2, 3. All right. So 1, then you cover all the elements in the first column, first row. So I'm going to cover, so I picked 1, 2, 3. Now I cover each element that I'm working with. I cover its respective row and column. So row and column of 1. I ignore these two. If I ignore these two, I have a 2 by 2 matrix, right? And I write the determinant of this. This is 1 times 0 minus 4 times 6. Next, minus 2. So now I ignore this row and this column. I have a 2 by 2 matrix whose columns are this one and this one. So 0 minus 20. Plus 3, ignore this column and this row. 0 times 6 minus 1 times 5. Let's do that. So 1 times 0 minus 4 times 6. 0 times 0 minus 4 times 5. 0 times 6. 1 times 5. That is minus 24. Plus 40 minus 15. That is, what is that? 1. So 1 over 1, which is just 1, times adjoint of A. Now, how do we calculate adjoint of A? All right. Adjoint of A. Because we know that inverse of A is 1 over determinant of A times adjoint of A. We got the first part, determinant. We found that. To find the adjoint of A, you need to go through this process. First, write A transpose. All right. Then, so what is A transpose? You basically replace columns with rows. All right. Adjoint of A. So the first column is the first row, 1, 2, 3. Second column is the second row, 0, 1, 4. Third column is the third row, 5, 6, 0. Now, looking at the transpose, for each element of the transpose, each element of this new matrix that I wrote, what is that matrix? Rows and columns are changed. I use rows as columns, basically. Cover its row and column. I'm going to do the same thing I did for determinant, this time for all of those elements in this matrix. And then calculate determinant of the remaining 2 by 2 matrix and place it here. Here. Okay. What is that? It means whatever you find, whatever value you find. First one is multiplied by +1. This one is multiplied by -1, and so forth. All right. So I'm going to do the same. So first element in that matrix is 1. I'm sorry about that. It's 1. I'm going to put it here. And it has a positive sign, right? I'm going to put it here. What do I put here? I ignore the column and row of that element. So I ignore these two. And I'm left with a 2 by 2 matrix. And I put the determinant of that here. What's the determinant of this? 1 times 0 minus 6 times 4. So that's minus 24. Minus 24. Now, next element is here. Oh my God. Next element is this guy, 2. I'm going to put it here, but it says it has a negative sign already. So I'm going to put a negative sign here. Whatever value I find, I put it in this parentheses. So I have to ignore the column and row of that, row and column. And I'm left with a 2 by 2 matrix, 0, 5, 4, 0. What's the determinant of that? 0 times 0 minus 5 times 4, which is minus 20. And I put that here. Minus 20. Okay. And I keep doing the same thing. First I get the determinant, then the adjoint, then multiply the two. 1 over determinant times adjoint.